All right. So now that we've talked about some different point defects that come across in ceramics, and again, drawing back to that idea that we need to have a balanced set of defects, this kind of brings us to needing a better way to communicate these defects so that we can write the combinations of defects that happen and keep track of charge and mass balance and all of that good stuff. And so that brings us to Kroger-Vink notation. So Kroger-Vink notation is the system used to describe defects in ceramics and ultimately get us to a point where we can kind of write chemical reactions, but talking about defects and not just chemicals. And so here's our little joke here. So this is kind of Kroger-Vinkfin from Ghostbusters. So again, bad joke. But here's the kind of the heart of the Kroger-Vink notation, and it's not that complex. So we have a way to describe a defect, and it's basically these three things. The first thing is the species. So what defect is it? Maybe it is a chemical or an element, right? So any of those things could be aspects of the defect. And then we have P here, the subscript. This is the position in the crystal, so it kind of tells you where it's going. So either the chemical name for the site it's taking, or an interstitial, or so forth, right? It's telling you the position. And then lastly, the C superscript denotes charge. And so here we keep track of the charge of a defect by denoting a dash for one negative, a dot or point for one positive, and an X for neutrally charged. If you have multiple charges, you would put multiple dashes or points to represent +2 or -2. So this is the kind of the idea of this Kroger-Vink. And so I just wanted to show you the basics here. And then what we're going to do is we're going to go over examples of this so you get a better feel for how to use the Kroger-Vink notation to describe defects. All right, so let's look at the Kroger-Vink notation in a little bit more detail. So again, we have the species, and a quick note here is that we can talk about an element, obviously, so talk about a sodium or potassium or titanium, but we also can talk about a vacancy as a species. And so we do need to represent vacancy, and so we actually use V to represent the vacancy. And you might realize that there's a conflict here, right? So vanadium has the chemical symbol V as well. And so if you have those, we won't work with any of those cases, but there is obviously a concern for if you're working with vanadium, then it has the same symbol as vacancy. So you might want to kind of maybe spell something out just to denote that. But again, we won't work any examples that have vanadium as a element, just to kind of keep that simple. The other part in this is that positions are denoted by the type of chemical that they're in, that usually takes that site, but we can also talk about interstitials. So interstitial is a position. And so to represent interstitial, since we don't have the terminology for that yet, we use the lowercase I for interstitial. So those are the kind of couple clarifying points that I wanted to make here in terms of how we represent these.